Welcome to the CompTIA A+ Prepcast presented by baremetalcyber.com. Network installation and troubleshooting require more than just technical knowledge. They demand hands-on skill with a variety of physical tools. These tools allow technicians to terminate, test, trace, and analyze both copper and fiber network connections. Common tools include crimpers, punchdown tools, toner probe sets, cable testers, multimeters, and analyzers. Each tool plays a specific role in the life cycle of a network, from setup and expansion to ongoing maintenance and diagnostics. The CompTIA A+ certification exam expects candidates to understand these tools not only by name, but also by purpose, procedure, and potential failure points. A crimping tool, or crimper, is one of the most frequently used items in a network technician's toolkit. It is used to attach modular RJ45 connectors to the ends of twisted pair Ethernet cables. Crimpers typically combine multiple functions into one handheld device, including wire cutting, insulation stripping, and the actual crimping action. The crimper presses down metal pins inside the connector, embedding them into the conductors of the cable to create both mechanical and electrical connections. A proper crimp ensures signal continuity and a physically secure termination. Using a crimper begins with stripping the outer jacket of the cable to expose the internal wire pairs. Once the wires are separated, they are arranged in the correct color sequence according to the T568A or T568B standard. The wires are inserted into the RJ45 connector with care to ensure full contact and proper alignment. After double-checking the arrangement, the connector is inserted into the crimper and the handle is pressed down firmly. This motion forces the pins to pierce the wires, locking them into place and completing the termination process. Crimping mistakes are common and can lead to a wide range of connectivity problems. One of the most frequent errors is misaligning the wire order, which results in an incorrect pinout and prevents proper communication. Other problems include wires that are not fully inserted, insulation that has not been stripped cleanly, or crimping without applying enough pressure. These issues can cause intermittent or total connection failure. Recrimping the connector or cutting off the damaged end and starting over is often necessary to correct a faulty termination. A punchdown tool is another essential instrument used to terminate twisted pair cables into structured cabling components such as patch panels and keystone jacks. Unlike a crimper, which works with modular connectors, the punchdown tool is used with insulation displacement connectors, IDCs. It secures each wire by forcing it into a metal blade, which slices through the insulation and makes direct contact with the conductor. The result is a clean, secure, and low-resistance connection that does not require soldering or additional stripping. To use a punchdown tool, the technician aligns the cable's conductor into the correct terminal channel on the patch panel or jack. The tool is then placed over the wire, and downward pressure is applied. Many punchdown tools feature spring-loaded handles that provide consistent force. As the tool presses down, it trims off any excess wire and seats the conductor firmly in the slot. Following the correct color code standard and maintaining proper tension are crucial for a successful termination. Improper punchdown technique can result in loose or misaligned wires that create performance problems or complete failure of the connection. If a wire doesn't make good contact with the blade inside the IDC slot, the signal may degrade or drop entirely. Reseating the wire, applying firmer pressure, or using a sharper blade may correct the issue. Poor visibility, incorrect tool alignment, and unfamiliarity with the wiring standard can all contribute to punchdown errors. A tone generator and probe set, commonly referred to as a toner probe, is used to locate and trace network cables. This is especially useful in environments where multiple cables are bundled together, run through walls, or extend through ceilings and floors. The tone generator sends an electrical signal down the length of a cable. The probe detects this tone and emits an audible sound that helps the technician follow the path of the cable to its termination point. To use a toner probe, The technician connects the tone generator to one end of the cable using alligator clips or an RJ45 adapter. The probe is then used to scan along cable bundles or within patch panels. As it gets closer to the cable carrying the signal, the sound increases in volume. This tool is indispensable for identifying unknown cable runs and verifying that a specific cable end corresponds to the correct destination. It's often used in data closets, ceiling spaces, and in troubleshooting mislabeled or undocumented cabling. While toner probes are invaluable for locating and identifying cable runs, they are not without limitations. One of the primary constraints is their relatively short effective range. Toner signals degrade quickly over distance and are especially susceptible to interference from electrical noise in the environment. If a cable is running alongside high-voltage power lines or through an electrically noisy zone, the tone may become faint or hard to distinguish. Additionally, the cable must be disconnected from live network equipment before using a toner, as active signals can interfere with or even damage the probe. A cable tester is another critical tool used to verify the physical integrity of network cables. Basic testers check for continuity, ensuring that each wire in a cable is connected end-to-end without breaks. More advanced testers verify correct pin order, identify split pairs, detect open or short circuits, and confirm whether the cable is straight through or crossover. Many testers use LED indicators to display the connection status of each individual wire, which helps pinpoint exactly where a problem is occurring. Loopback plugs are small devices used to test the transmit and receive functionality of network interfaces. By looping the outgoing signal back into the incoming path, these plugs simulate a live network connection and allow technicians to test ports on network interface cards, switches, and routers. They are also essential when using diagnostic software that checks for signal response or link negotiation. Loopback plugs are available for both Ethernet and serial ports and are especially useful for isolating hardware issues. Multimeters are versatile electrical testing devices used in network environments for various purposes. Technicians can use a multimeter to measure voltage on Power over Ethernet (PoE) ports, check cable resistance, or verify continuity. For example, if a PoE device is not powering up, a multimeter can confirm whether voltage is present on the relevant pins. While not specialized for network use, multimeters provide a valuable way to diagnose power-related issues or detect electrical faults in infrastructure cabling. A cable stripper is a basic but essential preparation tool used to remove the outer insulation from network cables. Whether working with twisted pair or coaxial cabling, technicians must strip the cable carefully to avoid nicking or damaging the internal conductors. Many strippers are adjustable for different cable types and diameters. A clean, accurate strip ensures that wires are properly exposed for punching down or crimping, which is critical for maintaining signal integrity and minimizing the chance of mechanical failure. Time domain reflectometers, or TDRs, are advanced diagnostic tools used to detect faults in copper cables. TDRs send a signal down the length of a cable and measure the reflection of that signal to determine if there is a break, short, or other irregularity. The time it takes for the reflection to return is used to calculate the distance to the fault. TDRs are useful for locating precisely where damage has occurred in long cable runs, saving time and effort when repairing buried or wall-embedded cables. The fiber optic equivalent of a TDR is the Optical Time Domain Reflectometer, or OTDR. It performs the same basic function, sending light pulses down a fiber line and measuring reflections to detect splices, breaks, bends, or poor connector installations. OTDRs also display a graphical trace of signal loss over distance, allowing technicians to visualize the quality of the fiber and pinpoint the location of issues. These tools are essential in fiber installations and maintenance, especially when cables are buried or stretched across long distances. Wireless analysis tools such as Wi-Fi analyzers are essential for evaluating signal strength, access point placement, and channel interference. These tools scan the environment and display nearby SSIDs, signal levels, frequencies, and sometimes security types. In crowded wireless environments, analyzers help identify which channels are congested and where access points should be relocated for better coverage. They are critical for optimizing performance and ensuring reliable wireless service across multiple floors, rooms, or building areas. Packet analyzers, also known as protocol analyzers or network sniffers, allow technicians to capture and interpret network traffic at a granular level. These tools can be used to diagnose dropped packets, latency issues, protocol errors, or unauthorized traffic. Tools like Wireshark or TCP dump can reveal detailed insights such as retransmissions, malformed packets, handshake failures, or excessive broadcasts. Packet analysis is especially useful when diagnosing intermittent or complex networking issues that are not visible through basic testing tools. In summary, network tools can be grouped into 3 categories: installation, testing, and diagnosis. Crimpers, punchdown tools, and strippers are used to build and terminate physical connections. Cable testers, multimeters, and reflectometers help verify those connections. Toner probes, analyzers, and loopback plugs assist in diagnosing deeper problems within the network. For the A+ exam, understanding when and how to use each tool is critical. Many exam questions are scenario-based and may require matching the correct tool to a given network condition or installation challenge. Thank you for listening. Please visit baremetalcyber.com for more cybersecurity information, podcasts, books, and more.